Good evening, everyone. Welcome to the October edition of the Astronomy Fundamentals program of the Naperville Astronomical Association. I am Drew Carhart. I'm the current club president, and I'm going to be your tour guide again this evening for tonight's subject. As per usual, if you have any questions or comments that you would like to pass along in real time, you can use the comments column on Facebook if you are following us there, or you can email to questions@naperastro.org. And Jim is following both of those from the control room, and he will pass them along to me. With the nature of tonight's program, I'm going to be covering a lot of topics, and I think maybe what we'll do is kind of hold the questions for him to pass along to me towards the end, because it's going to be a little hard to tell in the first 5 minutes what question I'm going to answer next. So go ahead and ask them in real time, and Jim will assemble them. And like I say, then we'll tackle them all at the end, at least the ones that haven't been answered so far. So let me find my little mouse there because I need my pointer. Tonight's topic is choosing your first telescope, and actually I put a little bit of a subtitle on that, and I'm going to call it choosing your first telescope or your first real telescope, because people sometimes end up with telescopes that they've bought or that they've gotten as gifts, that, or at least things that were called telescopes that were purported to be good for you looking at the sky with, and then ended up really not working too well. So sometimes you get a telescope like that and you're like, get very disappointed in the hobby because you don't see anything very well. But it's time then to get what amateur astronomers would consider a real telescope that'll actually do the job for you. But that's a kind of complex subject, because there are, oh, there we go with our subtitle, there are a lot of telescopes out there. Pardon that I'm covering up the little ones up in the corner, but down there are telescopes. There's actually a bewildering array of sizes and kinds and shapes and models and configurations of telescopes out there. And it can be really confusing, especially when you're starting out, to figure out what the differences are and what might really be the best telescope for you. A lot of people look and are just puzzled by it all. So what I'm going to try to do tonight is do what, if you Googled the subject of choosing your first telescope, you'll probably find many thousands of web pages and YouTube videos and things that cover this topic. But I decided to actually go at it in a little different direction than you might see elsewhere, or that I've actually organized in talks that I've given in the past. So what I want to do is take you from where you are right now, if you are thinking about getting a telescope, up to the point where you're looking through the eyepiece and enjoying views of celestial objects. We're going to go kind of chronologically that way and stop along the way and talk about the different things you're going to run into and how those different questions and options that you run into really need to be answered to be able to go back to this beginning step of what telescope should I be looking for. So to start out with, this is again the steps up to getting celestial objects in view from where you are tonight to that point. Step number one is the obvious one of the decision-making process of how do you decide what telescope you should get. Well, here's a first step you can take, and you're doing it right now. You could watch this video, because I'm going to give you a lot of introductory ideas about that. You can read more. There's a lot of resources online and magazines and books about how telescopes work and the variables between the different ones. This is something that I can't really overemphasize. It's just really wonderful to be able to actually talk with experienced telescope users, with people out there who have telescopes hopefully been using them for more than a week or two or whatever, and if you've looked through a lot of different telescopes or used different telescopes, and really get some live input on practical differences and practical aspects of different models of telescopes. So probably the best way of doing this is to find a local astronomy club wherever you're located. I know we're starting to have viewers scattered around beyond the Chicago area where we are now, but find a local astronomy club, or at least somebody in the area you live in that's interested in astronomy who might be able to even let you look through telescopes and things like that, and answer some really practical questions. The step number 2 in the road to looking through the eyepiece will be purchasing something. So let's look at the options there. Number 1 is developing your budget. And this really can't be understated. You can spend a moderate amount. A real telescope, new or used, you might save some money in the used market, but you're probably talking about spending a couple $100 to get a real telescope at minimum. It's set up and ready to go to give you good celestial viewing. On the top end of that scale, you can spend an astronomical amount, pardon the pun. You could spend as much as some people would spend in a house. You could spend on telescopes and things. So it really is very practical. You have to think about, how much do I want to invest in this? If all you want to invest is $10, your odds of finding something good are very low. Find somebody who's selling, a few $100 telescope for $10, that would be great. But you have to be realistic in budgeting. But having a budget is a starting place, and it should be on your spreadsheet of making your choices. And it's a very practical way to start. Let's talk about vendor. Where are you going to buy this telescope from? So the used market that I already mentioned is a definitely good place to look. A well cared for telescope will really never wear out. There are some exceptions. The more complex the electronics get on telescopes, the more likely they are to wear out earlier rather than later, but the optics of a good telescope should last lifetimes. And so if they're cared for well, a used telescope can be really just as good as a new one. So, and if you save some money there, that's an ideal thing. There's the big box store. People buy more telescopes at those places than some of us would like, because from the amateur astronomers, heartfelt recommendation, never go to a big box store to buy a telescope. If it's next to the paint aisle and the socks aisle, and there's one telescope sitting there, it's probably a really risky thing to buy. Even big name manufacturers who have fancy nameplates and are well known for good telescopes have been known, at least in the past, to produce models, especially for the department store type sale, that were actually very poor quality and didn't live up to the quality they would have on a more expensive, really amateur focused telescope. So it's really a risk to get the one you saw on sale at the place where you also buy motor oil and your underwear. So what does that leave? It leaves specialty stores that really specialize in selling telescopes, that sell many different models, many different brands, and sell a lot of telescopes. You probably don't have a store like that in your neighborhood. There might not be a store like that in your state, because frankly, not a lot of telescopes are sold overall compared to a lot of other consumer items. So there's not a market for having a big telescope store in every city or even every county or state or whatever. So that means going online. That's where most amateur astronomers end up buying the serious equipment they buy, is from specialty marketers that are might well be located out of state from where you live. So don't be afraid of that. That's something that you'll find the majority of serious telescopes are purchased in that manner. Number 3 is the observing list. So this is something that amateurs do before we go out to stargaze. Say if I was planning on going out this Friday night, I would make an observing list. I would see what's up in the sky and decide what objects I want to make and write it down. Well, in this case, your observing list is what you're interested in ever looking at through your telescope. And especially if you have certain things up there in the heavens that really intrigue you, that you want to focus on. Now, why is this important to think about this at this time when you're developing this plan to buy a telescope? Is different telescopes will be better, more optimum for looking at different objects. So you don't want to get the wrong telescope at this point for the thing that you really want to be observing. Now, how do we look at the variables in here? The first one would be, how big are the objects that you want to observe? And I'm not talking about how big in space, the fact that Jupiter is bigger than Mars or whatever, but how big do they appear in the sky to us? Because we use telescopes to give us a view, and we want to magnify the view enough so that object is clearly visible to us. But how much do we need to magnify? That depends on the types of objects you want to see. And this isn't something that might not be immediately obvious to somebody who's just starting out as an observational astronomer or a telescope user. But to show you a little example, yes, each telescope that you have has a useful range of magnification and practicality. And so if you have 2 refracting telescopes, that these 2 here in this diagram are the same diameter, they would have the same lens size in the front of them. But this one is shorter than that one, than the lower one. Why is this? Well, this lens here has a shorter focal length, the objective lens of this telescope, than the focal length of the longer telescope. Otherwise, they gather the same amount of light. If this is, say, 80 millimeters or whatever, you've got an 80 millimeter diameter lens in either case, gathering that light from the sky. So you're getting the same amount of light in. But with telescopes, the magnification that you see out through the eyepiece is this simple formula where it's the focal length of the telescope divided by the focal length of the eyepiece. So a telescope with a longer focal length, like the lower one here, is going to have a larger number divided by the focal length of the eyepiece. So if it's with the same eyepiece in either of these telescopes, the lower one is going to give you a higher magnification. If you just guess at it here, it looks like this telescope is almost 4 times as long as that. So in effect, if that was the case, the lower telescope with the same eyepiece in it would give you 4 times the magnification of the upper telescope. Now that doesn't make the bottom telescope better than the top one. They could both be excellent telescopes and they both be very useful for things. But the range of useful magnifications I refer to up above here will be higher for the longer focal length telescope than it is for the shorter focal length telescope. Eyepieces only come in a certain practical range of focal lengths, and a telescope can't push outside of its ideal range well without starting to give you problems with either distorting the image or not giving you a clear image if you try to push the power higher or lower than the comfortable range of the telescope. So that number, the focal length, which as I note here is usually expressed in millimeters nowadays, but you can occasionally still see it in inches. You can multiply the inches by 25.4 and get the millimeters to figure out equivalence. So that number, as I note here, can be used to compare any 2 telescopes, whether it's your little telescope and a giant one in an observatory, or your little telescope and your big telescope, or totally different designs of telescopes. They're all going to have each have their own focal length, or so I don't get hate mail from really nerdy astronomers out there, their own effective focal length you talk about in some telescopes. But that focal length you can use to compare any two telescopes, just like we use the diameter of the telescope to compare two telescopes. Those are actually the two important numbers to astronomers in a telescope, is the diameter and the focal length. So any telescope with a longer focal length, more millimeters, more inches, will have a higher useful range of magnifications than one with a lower focal length number. So that's how the magnifications will be different from telescope to telescope. What that means in the sky, here for this example, I've drawn a circle that we're going to say is a half a degree across. So this is, say, how big the sun or the moon look in the sky. They both take up about a half a degree of our field of vision when we see up in the sky, or about the size of your thumbnail if you hold it out at arm's length, up against the sky. What your thumbnail covers is about a half a degree across also for the size of the sun or moon. So that's that dot in the sky. You might want to look at the moon, and if you have a telescope that can get a field of view that's bigger than a half a degree, you'll see the whole moon. If your telescope has such high magnification that it can't give you a whole half a degree field of view, then you can't see the whole moon at one time. But let's look at some other objects in the sky. A lot of the things we look at beyond our solar system are actually fairly big in the sky. The star cluster M13 is a lovely globular cluster. The bright part of it that we normally see is about a half of this picture here, but this is a big thing. It's not a small dot in the sky. It's not like a star. It takes up a big area. It's a good portion of the size of the moon. Here's another star cluster. Here's a galaxy. Again, the bright part of it that you'll see in a smaller telescope isn't quite as big as this full extent that the diagram is simulating here, but it's not a tiny object. Even the Ring Nebula, which seems fairly small on a telescope, is relatively fairly large here. So for viewing a lot of these objects that are way out there in space, we don't often use really high magnifications. Even with a really large telescope, you might view objects like this at 30 power or 60 power or 90 power, or times or magnification, whatever you want to call that figure, which aren't really high numbers. But you don't want generally to see M13, you want to see all of M13, not just the inner core of it or a few stars over here in it or something or other. So we're oftentimes, again, in lower power ranges for a lot of the objects we look at, no matter how big a telescope we've got. On the other hand, if you go and look at our own solar system, some things get pretty tiny in the sky. Here's Jupiter and Saturn at about as big as they get from our perspective here on Earth. They're pretty small. Here's Mercury, Venus, and Mars, each shown at their largest when they're the closest to Earth, and their smallest. Here's Mars about now, and Mars what it looks like when it's on the opposite side of the sun. Goodness, look at Uranus and Neptune down here. We've got Neptune down to 1 pixel on this drawing here because it's very tiny in the sky. So if you're really interested in looking at the planets and really want to study them much, you're going to want to use higher magnifications. Looking at Saturn at 30 power, like I just said, you might use for some of the deep sky objects, you'll barely notice the rings on it. They'll be there, but there won't be much detail to them. They'll look kind of like they do in this picture, just like bumps on either side of the planet. You can see the bumps of the rings actually with binoculars, but they don't show up very clearly. If you want to see that up closer, you're talking about looking at Saturn at 100 power, or 150 power, 180 power, or maybe 200 power or more on a good night. So if these were in your really big wish list of what you want to be able to observe well, you're going to want a telescope with that useful range of magnifications that's up higher, that's in the range here of that 100, 200 power or even more that will deliver better views of the planets like this. So again, the observing list, like this number 3, it's actually an important thing to consider when you're telescope shopping. Second thing on the observing list is how bright the objects are that you're planning on observing. And this varies a lot too. This is a little harder to show graphically, but here I've made a chart that compares the surface brightnesses of various objects that we look in the sky. Now, this isn't the total brightness. If you read about astronomy, you're going to see the word magnitude listed a lot, and you'll talk about the magnitude of Jupiter or the planets or these deep sky objects. But that's the total combined magnitude of the light altogether. For what we can see with our eyes, what we need is not just the total magnitude, but how bright the surface is of things that are extended. For stars, stars are pinpoints. So it's really only the magnitude that matters. No matter how much you magnify them, they should stay pinpoints until all the light is in one spot. But for an object that has dimensions to it, like the face of a planet or the face of a galaxy, the brightness of one little square part of that face is what counts as to whether we can see it well or not. Down at the bottom of the chart here, you can see the magnitude per square arc second. So that's looking at that area that we're looking at and the brightness of that area. So what we see on this chart, we've got the brighter things over on the left here, with the moon leading the way here. The sun would be way off the chart there somewhere, but the moon's our bright guy here. And then Jupiter is fainter than the moon surface-wise. Uranus and Neptune are getting fainter yet. The reason being that they're farther from the sun. So the sunlight is fainter out there. So even though Jupiter is a fairly light-colored planet, it doesn't reflect, and actually Jupiter is a brighter surface on it than the moon has, reflectivity-wise, but the sun's quite a bit fainter out at Jupiter, and so it looks fainter in the sky to us. On the other side of the chart here, where we're getting off fainter, we've got nebulas and star clusters and galaxies. And this is, as though it's down here, a logarithmic scale. So actually, this isn't a linear thing. This is going out logarithmically. So it's kind of compressed, oddly. But we're getting fainter and fainter. And what the obvious division here is, as I put the arrows underneath, the planets are going to be in the brighter end of things you're looking at, and the deep sky things, the things beyond our solar system, are going to be in the fainter end. So what does this have to do with picking out a telescope? Well, the diameter of the light gathering part of your telescope, the lens in the front or the mirror in the back, determines how much light the telescope gathers. The telescope basically funnels light into your eye that falls onto the telescope. So the bigger the telescope is, the more light it gathers. And the more light it gathers, the better you'll be able to see fainter objects. So if you are primarily interested in observing the planets, you don't necessarily need a large diameter telescope because you don't need to gather as much light to see them well. If you're primarily interested in seeing the universe beyond and many of the fainter things out there, you might want more light gathering power to deliver better views of fainter objects. So there's another thing, again, that your observing list really comes back to helping you pick out the telescope. Again, if you only get one thing from this talk this evening, it should be that one telescope isn't the same as the next. So if you look through a telescope and you saw a certain view, don't expect the same view through every other telescope you ever look through, because there are differences like this, that focal length difference and this diameter difference. So again, here's a little telescope and here's a big telescope. The little telescope is simply not going to deliver the view of the faint things that the big telescope can. It's just the way it works. This one is funneling a lot more light into your eye than the little guy is. So not that you can't necessarily see some of these faint objects in the small telescope, but they're going to look smaller. You won't be able to magnify them much because the more you magnify something, the more you dim the light down, the more you spread it out. And you may need to be in a better place. You may need to be out in a really dark spot with a darker sky and away from the light pollution, and with your eyes much more used to the dark to be able to see some of these fainter things in the smaller telescope. So at this point, the question is, hey, Drew, which design is better for which objects? And you will find that there's a lot of opinions about that out there. So we have three basic optical designs. The first one over here being the refracting telescope with the lens in front gathering the light. The second one being a reflecting telescope with a mirror that gathers and focuses the light. And the third one being the combination, the catadioptric telescope, which uses multiple mirrors and oftentimes a correcting lens too, to gather and focus the light. In reality, the telescopes are all doing the same thing. You've got starlight entering in, or your celestial light entering in. The objective, whether it's a lens or a mirror, is focusing the light down into an image at the focal plane of the telescope. And then there's an eyepiece that is magnifying that image for your eye to look at. So again, the same thing is happening in all three of these telescopes. The light is being gathered, focused to an image, and then made observable. It's just done in a different manner. Now, again, you will probably find no end of recommendations from astronomers and would-be astronomers about how this one is good for that, and this one is good for that, and this is good for the other. And since you're listening to my talk, you're going to get my very heartfelt and very much based on experience opinion that it really doesn't matter. What really matters is the quality optics of your telescope, much more than the optical design that you end up choosing. For instance, the refractor telescope with the lens in the front. Some people would opine that this is the best kind of telescope for looking at the planets with, for getting good, crisp, clear views, high contrast, well-magnified views of the planets, better than either of the reflecting telescopes. In my opinion, a good quality reflecting telescope, like this Newtonian reflector here, can blow the socks off of a poor quality refracting telescope. It could be 100 times better than a poor quality refracting telescope. Same thing with the catadioptric design. Quality is everything. There's a theory about what this might do, this one might do that the other one might not do or whatever, but this is the practical world that we live in, that you're going to find when you make the right choice or the wrong choice of buying a telescope, is that quality is going to be what determines what you see in the telescope, because these are all three, and most of the designs of telescopes you find are basically good designs in theory. It's how well executed that makes the difference, really. Along the lines of that, the other issue is that the quality of the mounting that the telescope on is just as important as the optics. It doesn't make any difference if you have the best telescope in the world that anybody's ever seen. If it's on a mounting that is hard to point at something, or won't stay pointed, or shakes, or is otherwise not doing its job, it doesn't make any difference how good the telescope is. So the mounting is equally important to the optics. I could point out too that the optics I'm talking about here include the eyepiece that you're looking through, that lens set at the end there. It is possible to have a good telescope and have the view ruined by a poor eyepiece, but it's not really common. There's actually probably more poor telescopes that I've certainly looked through than I've looked through poor eyepieces that have been made in the past 30 or 40 years. But it is possible to have a bad eyepiece too. And it's kind of the weak link. If there's a weak link in your system somewhere or another, that's going to limit what you see. But again, so that's my answer to that question of but shouldn't I get one of these to do this certain thing with? Well, for visual observing, no, I don't think that that makes a difference. If you get a good quality of any of these telescopes for basic visual observing, you're going to be happy with it. Okay, step number 4, you've bought your telescope there. Now you've got to bring it somewhere, whether it's out into your yard or some other location, and you need to set it up. So what does that involve, and what are the variables here? Well, here's that little telescope, and here's the big telescope. The little telescope stays assembled all the time. You put covers on it, and it sits on the bookshelf or something. And when you want to observe, you take it outside and take the cover off, and you're observing, basically. The big telescope comes into pieces. Even taken apart, the pieces can be heavy and bulky. Then you have to fit them in your car or whatever, or carry them into the backyard, and you have to set them up, and you have to put it together. So there's a different amount of work between those two things. As far as setup goes, if you have this simple, what we call an altazimuth mount, it's just a bracket that holds the telescope and lets it pivot up and down and around in a circle so it can point at any part of the sky. That's something, once again, you can have set up. You can take out of your car, unfold the tripod, stand it up, and you're observing. This much more complex setup has a mount that has to be aligned to the North Pole, or to the compass direction north, and to the right elevation for the place you're observing at. And then the telescope has to be, after being assembled, like this other big one here, it has to go through an initialization process where you get it, all of its parts working, all of its machinery working, so you can use it. Is one of these better than the other? No. They're two different ways of mounting telescopes. Is this one faster than that one? Yes. Is this larger one, have more capabilities? Yes. It's also got a computer on it and things like that. So again, one of these 4 isn't the best. It may be the best for you or for a certain person in their particular situation, but best overall, no. If there was one telescope that was best overall, all amateurs would have that telescope and there wouldn't be anything else out there. But again, they're just differences. In the end, these issues, though, are something that you should address and decide what's right for you. This size and weight thing and this complexity thing. What seems right for you? Because, and this is something, I didn't come up with this, but I'm in full agreement with it. I don't know who the first person said it was, but the best telescope for you is the one that you will actually use. A lot of us amateurs have certainly known the people who have, if we're not those people ourselves, known the people who have gotten a really big or a really complex telescope and found that they never actually used it because, it's the end of the day and it's clear out and you're thinking you should take the telescope out. But when you think about the drudgery of taking it out and you don't do it, maybe the view is only a quarter as good through your small telescope. But if you got that out and used it, then it's a better telescope than the one that's in the closet that you didn't set up. So again, this is kind of the golden rule. The best telescope for you is the one that you will actually use. That's why thinking about these things and the other variables that I've touched on and that I'm going to touch on yet, why those are important things. So we're up to number 5. You've got your telescope set up wherever you're observing, and you have to find objects. So here's the scale. You can start at one end of the scale and do things manually, and on the other end of the scale you can have a computer do things for you. And once again, we're not talking about the right way and the wrong way. We're talking about the variable of this and deciding where you want to be on the scale, because you can get telescopes that are totally manual. You can get telescopes that are totally automatic. This isn't one of them, but you can get telescopes now that you basically, after you lug it out and put it in your yard or wherever, you basically turn it on and start it up, and then you go in the house and it aligns itself, it figures out where it is and what time it is, it thinks of what objects it should show you, it finds all those objects, and then it turns itself off, and you never even had to go out and observe. No, I think that's not one. It finds an object for you, and then you go back out and it's there waiting for you. And that's a thing that you can do that's at the other end of the scale from manual. And then there are telescopes in the middle, like this one has a computer on it that once you tell it that it's pointing at a certain star, it can look up in its catalog and tell you how to get to other objects. You have to push it to those objects instead of it slewing itself around, but it's in between. It's not fully automated, but it's not fully manual either. So again, there's a lot of options here. And once again, there isn't one that's the best. There isn't one that's the right way of doing it. I'm a manual person myself because I love star charts and I love finding my way around the sky. And that's right for me. I can fully understand somebody who doesn't want to know all of that stuff and would rather have the telescope do the finding for you. I often compare it to, and I think it's a valid comparison, to talk about going on a vacation. Some people like the manual method, where you get in a car with a map and maybe a guidebook, and you drive and you find things. On the other end of the scale, you book on a tour bus and you just sit back and you don't worry about where to turn or what road you're on or anything like that. You look out the window when the driver tells you to look out the window and see this site or that site or the other. And they're both perfectly valid ways of traveling. Some people prefer one and some people prefer the other. So it's exactly the same way with finding things with the telescope. I would point out that each method requires learning some skills. In the manual method, you need to learn your way around the sky. You need to learn your constellations. You need to learn about what your telescope can show you, so you know you're out of the big long list of objects that you find in a catalog or in a guide, which ones are worth looking at with your telescope and which ones aren't worth looking at. The automated system, you still might well have to learn your way around the sky some, because many of them require you pointing at a given star to start out with, or a given set of stars. So you need to know your constellations enough to handle that at least. You also need to know how to operate your manual system or your automatic system, what that device you're holding there with the buttons on it and the little screens is telling you, and what you need to do next and stuff to get it to do stuff. So there's learning required there too. It's not all just instant. You actually, if you have a go-to system, if you don't have a huge telescope, if it's on a smaller telescope, unfortunately the go-to system they put on a 60 millimeter telescope is pretty much the same that they put on a 20-inch telescope. So 3/4 of the things in the catalog of the go-to system, the 60 millimeter telescope won't show you anyway because they're too faint. So you need to kind of know that, or at least learn about that before you start saying, sure, find me all these objects you think are out there, because you're going to look through the eyepiece and see nothing in your little telescope an awful lot of times. So anyway, some skills are required. Some practice is required to learn how to use any kind of telescope. Once again, we go back to the important golden rule here. The best telescope for you is the one that you will actually use. Because again, whichever you choose, if it's not the right one for you, if it's frustrating for you or whatever, and you really don't want to take the time to learn it, or it just doesn't click with you, then it was the wrong telescope for you. You want the one that works for you. So, now, we get to the last item, which is observing. Now, what variables are there in the actual looking through the telescope that we need to think about before you buy the telescope? The first, or I should say the second one, I put the second one first because it's the less important one, but I wanted to mention it anyway, is the eyepiece position. So where physically in space is the eyepiece going to be located that you're going to be looking through? Do you need to climb up a ladder to look through it? Can you sit in a chair? Can you be standing? Do you have to crouch down to look through it? Different models of telescopes will put the eyepieces in all sorts of different locations. And some people do find some of them not very tenable. Maybe you don't want to stand on a ladder in the dark all the time. Maybe you love standing on a ladder in the dark. So maybe crouching down to look through a low-down telescope is going to get hard on your back after a while or something. So it is a consideration when you look at a telescope to think about, hey, what am I going to be doing when I'm looking through that eyepiece? Is that going to be a comfortable thing to do? To flip back to number one, variable here is, does the telescope track the sky? Does it have, it's actually the mount, as I say, that tracks the sky, not the telescope, but we're going to consider it a package, the telescope and mount. Does the mount have what we call a clock drive on it? So what a clock drive simply does is turn the telescope to make up for the rotation of the Earth and the way the sky, everything rises in the east and sets in the west. A telescope that tracks, in other words, you could put it on the moon as the moon is rising over in the east, and it would follow the moon. It would keep it in the telescope all night long as the moon goes across the sky. What good is tracking? Well, it's not an essential thing. You don't have to have it on a telescope, but it can be very handy. Here we have two common telescope designs, the Dobsonian and this altazimuth mounted refractor, that don't have tracking on them. Here we have two telescopes, this Maksutov and this Schmidt-Cassegrain, or whatever this catadioptric is, that are on mounts that will track the sky. We go back to our idea of the objects we're looking at and the magnifications we're going to be using. When you're using lower power, you're looking at a wider area of sky at one given time in your field of view. So it takes longer for objects to move across that field of view because of the Earth's rotation. So having a telescope that doesn't track will be only moderately inconvenient in that case at lower magnifications. If we're over here looking at the planets, when you're at higher magnification, you're looking at a potentially much smaller area of sky. You can get to the point where you're looking at, say, 200 power to see the details on Mars tonight, or well, not tonight. It's kind of raining everywhere tonight. But at 200 power, Mars might move out of the field of view, from the center of your field of view, off the edge and away in a minute or less. And that can be kind of annoying. So you're all evening long, you're pushing your telescope to follow the Mars across the sky. Yes, the sky is rotating, or we're rotating underneath it. So having a clock drive when you're doing planetary observing, especially if you're going to stare at the planet for a long time, and using that higher magnification, it can be a notable benefit. Is it absolutely important? No, you can certainly observe without it, but it's more of a benefit when you're at higher magnifications. So here we are, about 45 minutes in, and I've run through everything that took you from tonight to being out looking through your eyepiece, and tried to touch upon all these telescope design variables along the way that you run into in doing that. In summary, again, for the decision-making process, it's gather information. The purchase is locate the supplier for the model that you want. It's probably better to pick out the model and then go looking for the supplier, especially if you're ordering something online anyway. You don't have to put up with what's in your local store, because once again, you probably don't have a local store that has many telescopes. Your observing list, really think about the objects you want to see. And if you say right now, well, I don't really have a favorite, I just want to kind of sort of see everything, there are telescopes that are very much middle of the road, that are not ridiculously large, but big enough to see fainter things. They're not ridiculously long focal length, so you can get lower magnifications, but also still reach up into the higher end to see the planets. When I was growing up, the telescope that awful lot of amateurs got was a 6-inch f8. That means a 6-inch diameter f8 means it has a 48-inch or 6 times 8 is 48-inch focal length Newtonian reflector. I still have the one that I bought in 1971, I believe. It still works fine. It was a wonderful telescope, being very middle of the road. 6 inches is enough to gather quite a lot of light, so you can see fainter things. 48 inches is long enough that with normal eyepieces, you could get up to 180 or 200 power without any problem, and you could get down to like 35 power without any problem. So you had kind of that, you were in the middle of those ranges of things. So there you can, again, you can look for a telescope that's middle of the range. They still make 6-inch f8 telescope or reflecting telescopes. The transport and setup, that again, really think about it, that how much work do you want to do, because if you buy something that's going to end up being annoying to use, you're not going to use it, and that's not a good way to spend your money. Finding objects, where are you on that manual to automatic spectrum? What sounds good to you? Again, there's no right or wrong answer. It's your answer that you're looking for. And then the observing, that clock-driven or not issue, it's a real thing to ask. And again, if you want to discuss that more with other amateurs, like, would you live with the telescope without a clock drive? Ask somebody with a Dobsonian that doesn't have a clock drive, and they'll say, yeah, you do fine without it. But so again, each step along the way, we found variables, and we need to decide what answer to each of those variables, what value for each of those variables we would have to find a good telescope model for our needs. And that brings me to the end of my spiel. So Jim, are there any comments or questions out there to share?
Yes. Kind of a question or comment that Wendy had. So she said, essentially, as she's been researching this, she seems to think that you need maybe 2 telescopes. And she asked, is she way off? And maybe you can kind of address that. I know you have more than 1 telescope. What are your thoughts there?
Sure. Okay, for that question, number 1. So now we're kind of getting into the concept of the evolution of the amateur observer. When people are just starting out, we say, do something introductory, really basic. I didn't mention it at all tonight, but because this is a talk about telescopes, but one of the pieces of advice we often give to people who are really just dipping their toes into stargazing is get a pair of binoculars, because you can do a lot of observing with binoculars, and then you can also use them for more earthly pursuits more easily, and so they're more multi-purpose there. But if you're more committed up the scale from that, not that I don't have binoculars and use them all the time, but then getting a telescope is a thing. But if you find, I don't know that I would really, unless somebody just won the lottery and they needed to fill their garage with stuff, I would ever say go out and buy 2 telescopes. You might, advice-wise, you might think about that down the road, but still start out with a more basic one. Now, why do many amateurs, not most, but certainly, it might be more than half, I guess, at least people in our astronomy club who have telescopes have more than 1 telescope. And why is that? I think the basic reasons are that a larger telescope is very rewarding, and once you've started observing with a larger telescope, you really want to have one on hand. But you found that you don't always want to lug out the big telescope, that if you're going on the road and don't have room in your car, or you just want a telescope out for 20 minutes tonight, to look at one thing and then go back inside, having a smaller, more portable telescope is a really handy thing to have. I bought a 80mm refractor that's about 3 inches across when I was traveling to Europe almost 20 years ago now, and I bought it for watching the sun and moon, basically. And then it's a really nice telescope. I found after that I really started using it for a lot of other observing, and I use it a lot. because it's a great telescope and it's extremely portable and quick, easy to get out. There's even a name for that now in the amateur astronomy circles of the grab and go telescope, the one that's can be set up in the corner. Well, I'm pointing at a telescope set up in the corner. I'm pointing at one that's set up over that corner. It's all taken apart in pieces because it's quite a large telescope. But the grab and go, I could have that outside in 2 minutes looking at something, and there's a value to that. So I don't know if that really answers the question, but yeah, it's really common for people to do that, and it's mainly the size thing.
So the same person, Wendy, also asked, she was asking this when you have the pictures up of the different telescopes, do any of these require more or less maintenance? Can you kind of talk about collimation and the things there?
Sure. I don't know if I want to scroll all the way back through 56 slides, but so there's basically two types of telescopes that it's a different classification that you wouldn't normally use, but there's the telescopes that need adjustment and the telescopes that don't need adjustment. The refracting telescopes, the one with a lens in the front that's doing the light gathering, those telescopes are generally pretty much a sealed package. Everything is lined up inside of them and locked into place, and you really never have to do anything in theory unless something bad happens to the telescope to set it up. On the other end of the spectrum would be the larger telescopes with mirrors in them that either just in transporting them, or if you have to dismantle them to transport them and then set them back up, each time you set them up, you're going to need to check the alignment of the optics. They may still be good, even if you dismantled and reassembled the telescope. I've got, again, a big one over here that does dismantle down, but it's machined well enough that when I put it back together, it almost always is still right on the money as far as alignment, but I have to check that. So that's an issue. The third type of telescope, the one with the combination of multiple mirrors and the corrector plate in them, in theory, those telescopes should also be fairly sealed, and they should stay put pretty well as far as the alignment of the optics in them. But that isn't always the case. Sometimes they can work somewhat out of alignment too. So yeah, it definitely depends on the type of telescope as far as whether that kind of work is always needed or almost never needed.
Okay, and then there's a question about, now this can be a very, very complicated question, but can you briefly speak about the kind of telescope, or maybe more so the kind of mount needed if you're doing astrophotography? Yeah.
So I think the most important thing to say about that is, well, there's two things. There's two different kinds of astrophotography. There's taking your cell camera and putting it up to the eyepiece and snapping pictures of things, and really simple stuff like that. And then there's serious astrophotography where you're putting special equipment in and using special techniques and special cameras and things to do image capturing. So those are two different things. You can do the cell phone thing with any camera, or with any telescope. So if that's what's crossing your mind when you say astrophotography, if you're thinking about what you see, if you get Astronomy magazine or Sky and Telescope magazine and see the wonderful pictures of things, you're talking about almost a different hobby than visual observing. Not that you don't use some of the same equipment, but your whole list of things that, like the 6 things that I go through on this list, are really different for doing astrophotography if you want to do it in the serious manner. So your observing list is kind of a totally different thing, because my observing list was based on you looking through the eyepiece to see things. If you want to photograph things, you're going to need to do different things. The number 6, the clock driven or not, is a given. If you're going to be doing astrophotography of serious nature, you have to be not only clock driven, but really well clock driven. You have to have a mount that's accurate enough to seriously well follow things, not just sort of follow things. So yeah, it's almost got to be a different talk. As a matter of fact, I think we have a talk coming up. Isn't December astrophotography and fundamentals? I think it is. So that will be the good thing to do is watch our upcoming list, and the I believe it's December is our fundamentals program is on astrophotography, because I like to say it's so much of a different spectrum now that there are telescopes that people get for astrophotography that you don't really use, that aren't really made to visually observe through anymore. Not that you can't go between one and the other with any telescope, but you really are in a different world.
Okay, and then Jim is asking if you can comment on the EV scope. Have you tried one, or what's your thoughts on that? He said he has one and he loves it. He also has a Go-To Mac that's great, but he's gotten much more use out of the EV scope week to week.
Well, so what he's speaking about there is there are at least 3 models in production, now of telescopes that you don't look through at all. It may look like you're looking through them, or it may not, depending on which one you get. They're telescopes with a video camera built into them, so it's actually the video camera that's doing the observing and then presenting to you a monitor image, a TV image, basically. So in some of them, like the EV scope, you're looking through a little magnifying glass. It looks like an eyepiece, but it's really not the same as a telescope eyepiece. But those 3 telescopes that I know of, the EV scope being one of them, are total packages with a computer inside them. They're one of those ones where you can take it out and set it on your deck and flip the switch in it and come back later. And or one of them, you don't even have to come back outside. You can sit in your house and look at the pictures on your phone. At least one of them is like that. Again, I would put it as a different experience. You can. It's probably the best way to start a fight in the pub after astronomy programs is to have people opine on whether looking at a screen is the same as looking through a telescope. I'm not saying there's a right or wrong. It goes back to the that gold rule question of the telescope that you use the most being the one that's the right one for you. And if looking at a picture on a screen is equal or better to you than seeing photons directly with your eye, then what I can't comment is on which model of those is the best. It's again, to me, it's almost like you're talking about a different thing than visual observing. So yeah, again, that's as much as my experience goes with them. So if you've visited our programming that we've done, our video streaming from our observatories, that's basically what we're doing there. We're using a video camera to capture and intensify the images of things, and then we look at them on the screen. It's the same thing you're looking at with these telescopes, but again, it's almost a different branch of observing than visual observing. So it's a little out of my purview for tonight. So
you kind of touched on this briefly, but Dave asks, is how you use the telescope, viewing or photography, another deciding factor? Do most telescopes cover both options?
Yeah, again, it really depends on what you mean by photography at this point, because that branch of the tree has really been growing off in its own direction from the visual observing branch of the tree. And there's overlap, definitely. If you see pictures that, like, people have been sharing, for instance, if you followed us when we were streaming with the Adler Planetarium for their Mars nights, they were sharing some photos that people in the local area had taken of Mars. Those were taken by taking a video segment, some minutes of video with many hundreds or thousands of frames of Mars through a fairly normal telescope. And then the computer looks at all of those frames and looks for details that are the same in every frame and gets rid of all of the blurry details and ends up giving you this really pretty image. So that's something done with moderate equipment on a normal telescope. But when you look again at the pictures in Sky and Telescope that people take that are total exposures of 6 hours or 18 hours or something or other of these incredibly faint deep sky objects, that's again, you're in a different branch of equipment for that. So there's not as much overlap between that and the visual observing anymore. So, but yeah, so I mean, we have a couple of members who do excellent astrophotography and use what's basically at the core a fairly normal telescope. They just outfit it differently. They take visual parts off of it and put astrophotography parts on it instead to take that kind of pictures.
Can you maybe just give your opinion on equatorial mounts for beginners? Like, would you recommend that a beginner get an equatorial mount, or would you recommend they stay away from that?
It really kind of depends on a couple of your other questions here. So the clock-driven thing, you don't even have to have an equatorial mount for that anymore, in that you can put your telescope like your Dobsonian telescope, which is not an equatorial mount. It's what we call an altazimuth mount. It goes around and up and down. And you can put that on a platform that drives the whole telescope and will have it track the sky. So it can be clock driven that way. If you're looking at a traditional equatorial mount, I really ought to, let's see if I,
So the question was from Elias. I assume that he's more referring to the Walmart special that has the equatorial mount, and not the multiple $1,000 equatorial mount.
I want to start from this slide. Well, we'll go through it. Sorry, current slide. That is not the current slide. Come on. Let's get to the picture with all the telescopes on it. Here we go. So I think what he's referring to is this guy up in the corner here. This is a traditional way of presenting a small refractor telescope, and this is what he's talking about as an equatorial mount. It's, to me,
I would say probably the other corner that's got that. That's got the something like that.
Well, for that big a telescope, it's certainly nice to be able to. I don't know if this has a drive on it or not. This is the kind of mounting. I don't know if you can see that, or am I covering it up? I can kill my camera. But, this probably has a drive on it. If it does, that's tracking. And so that's the main. So this telescope over here on this side has an equatorial mount. It doesn't have a clock drive on it, but it's got this knob on it, and another knob should be going the other direction there along the bottom, that you can use to manually easily turn the telescope to follow the sky. Those are really handy things. It takes longer to learn how to set this up, and it takes longer when you set it up to set it up than a telescope on a altazimuth mount like the Dobsonian next to it, or like a refractor on I don't have that refractor in the set here with the altazimuth mount. But the trouble with these mounts was they tended to get kind of cheaply made after a while, and they were just sort of clunky. If you have a well-made equatorial mount, I personally would always go for the equatorial mount, even though my good refractor I only use on a camera tripod, basically. But there's a lot of benefits. That's a personal taste thing, though. Again, what are you using it for?
Well, so Elias kind of chimed in again that, you have to align it properly. You have to polar align it. And I think some people's, like my brain works in left and right, up and down. my brain doesn't work the way the sky moves.
Sure.
So it makes it more difficult for me to use an equatorial because I get a little bit lost.
Well, again, so that's picking the right telescope for you and what works for you. I will say, so this mount up in the corner here, theoretically, this is tilted to work on the equator. So this is somebody in Bolivia using this telescope. This axis should be tilted up like these ones are. For us, it'd be 41 degrees, but you actually don't have to set it up equatorially. If you're just running outside to look at something, you can just point it at, what you want to set it, flop it down and point it at. It just won't slew correctly to correct for the Earth's rotation if you don't have it aligned right. But yeah, so my bigger telescope is the Dobsonian knockoff, sort of. It's a telescope on a ball, so it has no back and forth and up and down. It moves any direction you want, but I have a platform to set it on to track the sky, and that makes it wonderful to be able to watch the same thing for an extended period of time and not have it drift out of field of view. So again, there's a learning curve on anything, and it's, again, a lot like GoTo. I think some people would say, as far as the GoTo or not, as far as the way your brain works, some people would feel they'd have an awful lot hard time learning their way around the sky and remembering what constellation is which, but other people would say they'd have a hard time remembering which button does which on a stupid box. So yeah, it's again, it's a real personal thing. So. Anything else?
And then there was a comment by Jim. He said his observing stool is one of the most important things he has, makes observing very comfortable.
Yep. Again, so I pointed that out about where the eyepiece is. Thing about the Cassegrain type design, if you have it on a fork mount, like this guy is, these little telescopes on fork mounts, to me, these have always been problematic because you've got tripod legs and the eyepiece is always somewhere right over the tripod legs. But in theory, the eyepiece is always around the same height. So you might be able to have a chair that you can easily sit at without moving. If you have a Newtonian like this, or one of these ones at a Dobsonian base, that eyepiece is going to swing through a lot of space. It's going to come down by the ground when you're looking down low. It's going to be up high when you're looking up high. And so being comfortable is a trick, but as Jim very aptly pointed out there, you do want to be comfortable while you're observing. So it's something to think about. If you get a really big telescope and always have to be on a step stool or something, that might not be too comfortable. So it's something.
I know one of the first times I used a refractor, I was looking at zenith and I was sitting, like literally sitting on the ground to look in the eyepiece because
yeah. Or they make, so the Orion sells a lot. This isn't in Orion, but they sell a lot of their 4-inch Dobsonians, and that telescope, the eyepiece is often 2 feet off the ground, 2.5, 3 feet off the ground at most. And for a big person like me, it's like, well, I'm spending this evening on my knees looking through this telescope because it gets down so low. So it's something to think about again. So,
okay, I don't see any more questions.
All right. Well,
I hope I got everybody's questions to you.
I think have I just popped back up? If that's me. Well then, thanks everyone for attending. I hope that I did have a closing thing. I forgot about it. Let's see if we can get to that. I went to the trouble to make a closing slide. Let's see if it'll go. Oh, it didn't. I don't know where start from current slide isn't working, but well, anyway, what the closing slides said. It really is confusing. were that, I'll just look up the closing slides. Okay, visit us at naperastro.org on our website, or follow us on Facebook, Instagram, or Twitter. And we are now just developing a YouTube channel, which we've streamed so many events since this past spring that we've taken them, we've edited them down, gotten rid of some of the clunky spots, and we're loading them up onto our YouTube channel. So if you look us up there, you will be able to review everything we've done so far in a little bit neater format with descriptions on each episode. So we're ready to go with that too. So again, you just go to YouTube. Our channel there is currently, since we just started it, an incredibly long line of gibberish, letters and numbers for its address. So just go to YouTube and look up Naperville and Astronomy, and I think we'll probably be at the top of the list there that you find. But follow us there. If you subscribe, then we'll be able to change our name to something better than a big long line of gibberish. Anyway, for tonight then, thank you very much all for attending, and do look at our calendar for what we've got coming up. And if you follow us again on Facebook, or if you're a member and watch the club message board, we'll let you know when we do any pop-up observing. So take care, and once it stops raining, get back out and look at the sky, everybody. So good night.